Hello, this is Miss Moore, and today during chemistry, we're going to discuss scientific notation. Today's essential question: how do you convert from standard notation to scientific notation? All right, let's do this. So, first of all, why scientific notation? Well, in science, it's really common, you're going to find, to work with really, really big numbers or really, really small numbers. So for example, we have a drop of water contains approximately, I don't even know what that number is, 170000000000000000000000 molecules or particles. Now, drawing all those zeros is sort of a pain. It's easy to miss one. And even worse, if you have to do calculations, trying to put all those zeros into a calculator are really easy to miss a few or add a few, which could really change your numbers. It's a big number and it's really difficult to work with. Another example is the radius of a calcium atom, which is 0.0000000000197. Okay. Again, a number that's sort of hard to work with, hard to write down, hard to put in the calculator, easy to make a mistake. So we have this thing called scientific notation. Scientific notation is a way to write these numbers that's easier to keep track of all of these zeros. It takes a little getting used to using scientific notation, but it really, really, really does help. All right, let's proceed with what scientific notation looks like. So when a number is written in scientific notation, we separate the number into two parts. The first part is a number with one digit before the decimal and usually 2 digits after the decimal. Okay, so this number up here, that 0.00 blah, 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 we would be writing that first part, we would just be looking at these non-zero digits here, and we would have 1.97. Okay, now 1.97 is absolutely not the same number as 0.000 blah, 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 197, right? Totally different number. So there's a second part to this. So the second part is what we call an exponent. So now let me show you how this would be how we would work this. So this number here, 255,000,000, this is normal writing, and we call that standard notation. If we were to write this in scientific notation, we would write it as 2.55. So we have one digit before the decimal and 2 digits after, right? So that was this part A here. And then part B, we use this exponent, which is times 10 to the 7. Now, what times 10 means, it does not mean, it doesn't say 2.55 multiplied by 7. In this case, this times 7 really means, not this times 7, sorry, this times 10 here means move the decimal and the exponent, the 7, means 7 times. Okay, so look, if we have this 2.55, move the decimal 7 times, let's do it. We have 2.55, but we move the decimal 7 times. We're going to have 1, 2, 3, 4, 5, 6, 7, 2, 5, 5 with 5 zeros after it, which 255 with 1, 2, 3, 4, 5 zeros after it. Okay, so that's how we make a number written like this mean the same as that. Kind of go step by step and solve a problem. So how to write numbers in scientific notation. So the first thing you do is you look at the original number. So we have the same original number I was just talking about. And you rewrite the number so that there is only, Rewrite the number so that the number is only one digit before the decimal. And by the way, when I say one digit before the decimal, I mean one non-zero digit. Okay, so here's our number rewritten. And if we want only one digit, one non-zero digit before the decimal, we're going to place the decimal right there. Okay. So then the next step is to count the number of times the decimal needed to be moved so that there is only one digit to the left of or before the decimal. This is going to be your exponent. So if you have a number with no decimal, remember an invisible decimal is behind it, right? That's where your invisible decimal goes. So let's move the decimal and see how many times it took us to get it between the 2 and the 5. So 1, 2, 3, 4, 5, 6, 7. It took 7 moves. That's our exponent. So what we really want is 2.55. Move the decimal 7 times. We really only want 2 digits after the decimal. I don't need all of this junk. So I'm going to rewrite it as 2.55 times 10 to the 7th, or 2.55, move the decimal 7 times. So hopefully this isn't too bad. It's a little bit weird, but hopefully you'll get used to it. Okay, and before I move on, one really important thing is the exponent could be either positive or it could be negative. The way you tell is it's positive if you have what I call a big number. I think big would be positive, right? A big number is if the original number is 1 or bigger. It'll be negative if the original number is less than 1 or a small number. So, for example, if I had 2, 5, 5, 1, 2, 3, 4, 5, when we write that in scientific notation, we just did this. It's 2.55. Move the decimal 7 times to make a big number, right? This number is definitely bigger than 1. Okay, but what if my original number was something like so I'm going to have 2.55, so I have 1 digit before the decimal. So the decimal is between the 2 and the 5. How many times did I have to move decimal to get there? 1, 2, 3, 4, 5. So times 10 to the 5th. But that can't be right. But our original number here is a small number. So it says it's 2.55 times 10 to the negative 5, indicating you're going to move the decimal to make a small number, or you're going to move the decimal to the left. All right, hopefully you feel okay about turning a standard number into a scientific notation. We will practice this, but another point I want to go over is rounding. I think it's good practice. Hopefully a lot of you know this, but it's easy to forget the little points. So when you're rounding, for this class, what we're going to do is we're going to keep 2 digits after the decimal. Okay, so if there's less than 2 digits after the decimal, add zeros, because that won't really change anything. For example, if I had 2, that's the same thing as writing 2.00. Okay. If there are more than 2 digits after the decimal, you need to round. Okay, so how do you round? If the first digit you are going to drop is 5 or greater, you're going to round up. So let me give you an example. I'll keep with the 2 point something. 2.54572. Okay, so when you're rounding, look at, we want 2 digits after the decimal, right? So we're going to keep these. Look at the first digit you're going to drop, which is a 5. It's 5 or bigger, which is going to turn our 4 into a 5. So we're going to end up with 2.55. Okay? If instead the first digit you are going to drop is less than 5, simply drop the digits. So if I had 2.54276 something something something, we're keeping again the 2 and the 5 4. Okay, we look at the first digit we're going to drop, which is the 2. It's less than 5, so we're just going to drop everything, and our final answer will be 2.54. Okay, those are some real basic rounding rules. All right, scientific notation practice. If you think you know how to do this, go ahead and hit pause and try to do them on your own. Try to do number 1 on your own and see if you can do it, and then hit play and see how you did. If you don't feel good about it, listen to number 1, and I don't know why these numbers are all weird, but try to do as many as you can without my help, and then go back and look. Okay, so first step is we're going to look at our number, and we want the decimal to have only one non-zero digit before the decimal. So we really want our decimal to be right there, right? So I have 3.10, right? And then we look at the 2, which is, that's the first one we're going to drop. It is less than 5, so we're going to have 3.10. Now we have to move the decimal. How many times do we have to move it? Remember, if there is no decimal showing, it's invisible, it's at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move it 9 times. Okay? And the original number is bigger than 1, which means it's a big number, so our exponent is positive. All right, let's try the next one. We want one non-zero digit before the decimal, which means we're going to put it right there. So we want our number to be 2.55. Move the decimal. Let's see. We had to move it 1, 2, 3, 4, 5, 6, 7, 8. 8 times. Our original number here is less than 1. It's a small number. Small numbers have a negative exponent. All right, let's try the last one. We want one non-zero digit before the decimal. We're going to find the very first non-zero digit, which is the 4. We're going to put the decimal right after the 4. So we're going to have 4.50. First number we're going to drop is a 0, which means we're just going to drop. So let me get rid of all this so it's not so confusing. So we're going to have 4.50, move the decimal 1, 2, 3, 4, 5, 6, 7 times. Did I get that right? 1, 2, 3, 4, 5, 6, 7. We move the decimal 7 times. Our original number is less than 1. It's a small number, so the exponent is negative. All right, that's it for scientific notation, going from standard notation. By the way, by standard notation, I mean regular. So this is standard notation. And scientific notation is the move the decimal with the exponent. So this is scientific. Okay, so we've learned now how to go from standard notation to scientific notation, right? We can go from standard to scientific. Next up, we'll be going the other way around, starting with scientific and going back to standard. So, how to convert from scientific notation back to standard notation. And this is not very hard. If you understand what this means, all you're doing is taking it out of standard. So to convert from scientific to standard notation, use the sign of the exponent to determine which direction to move the decimal. Remember, a positive exponent means that the original number is 1 or larger. It's a big number. So if you have a positive exponent, you're going to move the decimal to make a big number, which would mean you need to move it to the right. A negative exponent means the number is less than 1. We've got a small number. So a positive exponent means a big number. If you can remember that, you're going to be fine. A negative exponent means a small number. And the actual quantity of the exponent, the number itself, tells you how many times to move the decimal. So let's try a couple of these. Let's say we have 6.23 times 10 to the 6th. We know we need to move the decimal. Well, wait a minute. I said it's 6.23 times 10 to the 6th, which is what it says, but what it really says is 6.23. This means move the decimal. Six times. And it's positive, so we're going to be making a big number. Okay, so what way do we have to move the decimal to make a big number? Well, we've got to move it that way. So we have 6.23. We have to move the decimal 6 times to make a big number. 1, 2, 3, 4, 5, 6. There you go. Now, please don't ever give me an answer like that, because now I have no idea where the decimal is. You need to rewrite it. So I'm going to have 6, 2, 3 with 4 zeros after it. Okay, so this is scientific notation, standard notation. Okay, got another practice problem. Why don't you hit pause and try it on your own first, and then hit play and see if you can do it, if you did it right. All right, so the next one is 3.022. Move the decimal 2 times to make a small number. How do I know it's a small number? The negative. So we're going to move the decimal 2 times to make a small number. So now think about what way do you need to move the decimal to make the number small? Well, you'd want to move it back that direction, right? So we have 3.02. I'm going to move the decimal 2 times to make a small number, 1, 2. So it would be 0.0302. Now, by convention, you normally write a 0 in front of a decimal. If you don't, you won't necessarily lose points. The problem is sometimes people write their decimals really tiny and you can't see them. So but writing a 0 in front helps the reader to look at your number and say, hey, there must be a decimal there. All right, hopefully you feel okay about about generals of scientific notation. So that's it for today, and have a good one.